Alright, welcome to the, I don't know what number lesson this is in chapter 11. So we're going to be learning about the ratio of sides versus the ratio of areas today, of just regular polygons. Okay, so we're going to start by looking at the most basic shape, a square. So I'm going to draw a 2 by 2 and a 5 by 5. And I luckily already have nice little pictures here so you don't have to suffer through my drawing. Okay, so first, this was a 2 by 2, remember? And a 5 by 5. So I'm going to ask you two questions on this. All right, and it's first, what is the ratio between their sides? So the sides, the ratio between the sides is 2 to 5. All right, oh goodness, not used to these buttons yet. All right, and the second one is, what is the ratio between their areas? All right, so the ratio between the areas is going to be, the area of this one is 4, and the area of this one is 5 times 5, which is 25. So it's going to be 4 over 25. So hopefully you're starting to see connection that, oh, that's the same thing as 2 squared on top. And to get the area of the square, I did 5 squared to get the area of the second one. So that's one connection to make. Right, now we're going to do the same thing with triangles. So you want to draw a triangle with a base of 2 and a height of 4. So mine's not going to be pretty, but there's an example. Yours could also look like this. Okay. And then I also want you to draw on your graph paper a base of 5 and a height of 10. So, oops, yours is going to be much better. Something that looks like that. Alright, so luckily I already have two nice pictures on the next screen. So we want to find out what the ratio of their sides are. Now we obviously don't know what this side is or this side is, so let's just stick to the easiest. The ratio of the sides is going to be the same. They're similar. So the ratio of the sides is 2 to 5. Alright, and now we have to do some calculations to find the area. So the height of this was 2, or the base was 2, the height was 4, so that's going to be 1/2 2 times 4, which gives me an area of 4 for the little one. And the big one, remember, the base was 5 and the height was 10. So I'm going to get 5 times 10 times 1/2. So that gives me 25. So we get the same thing we did with the squares. Ratio of the areas is 4 to 25. So again, notice the base was 2 and 5 in that case. So we went from 2 over 5. That was our sides. And the area we found, areas to be 4 to 25. So hopefully you're starting to see a connection that if I have two similar polygons and the ratio of the sides is m over n, okay, then to get the ratio of the areas, you're going to get m squared over n squared. So pretty easy. So notice in the previous one we had 2 over 5, and we did 2 squared over 5 squared, and that's what always gave us the ratio of the areas to be 4 over 25. Okay? Right, so let's look at these rectangles and see what we can do with this new property we just found. Okay? So first, this one just asks us the most basic question they could ask. Find the ratio of the areas given that we have two sides. So again, to start, we're going to start with the ratio of the sides. That's 8 over 5. Well, remember it's m squared over n squared. So I get 64 over 25 for the ratio of the areas. The most basic one they can ask. Right? Now we're going to use these same two rectangles, and I'm going to give you a different piece of information. I don't want you to find the ratio of the areas because I've already asked you to do that. I want you to use what we already found, the ratio of the areas to be 64 over 25, to see if you can find the area of that smaller rectangle, given that this one has an area of 96. So go ahead and pause the video and see if you can set up a proportion that's going to give you that value. Okay, so I found the ratio of the areas to be 64 over 25 on my previous slide. Well, if I know the ratio of the areas, well, if the area is 96, it has to be the same ratio with that, whatever the small area is. So my proportion is 64 over 25 is equal to 95, or I just called it x. So cross multiply. I get 64x equals, I believe that's 2400. I'm going to divide by 64 to finish solving. And I get the area of the small one to be 37.5. So 37.5. And once you get that, always check, does it make sense? Well, that's a smaller rectangle. So it makes sense it's 37.5. It's about a third of the area, a little bit over. Okay. Right, so this one should be, again, the most basic one. Find the ratio between the areas. So now that we've done one, I want you to pause it and see what you get for the ratio of the areas. It should be quick. Okay, use the property m over n for the sides gives you m squared over n squared for the areas. So again, I'm going to follow what I just wrote down for you. 6 over 10 is my sides. In this case, it's a radius, not really a side. So then I'm going to go ahead and simplify that before I square it just to make it, oopsie, to make it a little easier for me. That's the same thing as 3/5. So now I'm going to square it to get my areas. So the ratio of the areas is 9 over 25. Hopefully you got that as your answer. Or maybe it wasn't simplified quite yet. Right, so now I have two triangles similar to those two rectangles, and I know the area of one of them. So your first clue should be, alright, I got to use these sides. So go ahead and use the sides. Find the ratio of the areas first, and then see if you can set up a proportion like we did with the rectangles to find the area of that triangle right there. So go ahead and pause and see what you get. Alright, so I hope you did this work as follows. Started with the sides of 7 over 4. Can't be simplified, so I'm going to go and square it to find my areas. So I get 49 over 16. Now notice that's the big triangle to the small triangle. Notice I'm trying to find the area of the big triangle, so that's going to be my missing variable, x I'm going to call it. And I know the area of the small one is 6, so my proportion is 49 over 16 equals x over 6. Cross multiply. 49 times 6 gives me 294 equals 16x. Go ahead and divide by 16. So I'm going to get the area of that small, or the bigger one, to be 18.375. Oops, that's a decimal point. So go ahead and check. Does it make sense that that big one is 18.375 inches squared? I hope it does. Alright, so now we're getting into something that's going to have us go backwards. Notice what they're giving us, the ratio of the areas. So the ratio of the area is 4 to 9. I want you to take a second here, pause it, see if you can figure out what the ratio of the sides is. How would you do that? So normally we square it to get the ratio of the areas, but since we know it, the opposite would then be 2. Square root, so the opposite of squaring, square root. So I get 2/3 for my sides ratio. Well, now I'm going to use that sides ratio to find the missing x and y. So the ratio of the sides on these two similar triangles is 2/3. Your 2/3 is the small to the big, so the small side is x on that triangle, and the big one that goes, the one on the big triangle that goes with that side is 6. So I get 2/3 is x over 6. Cross multiply, 12 equals 3x. So x is going to equal 4. So that side length is 4. I'm going to use that same concept now to find y. Notice now I have the small triangle side, and I need to put the y on the bottom. And when I cross multiply, I get 2y equals 4.5. So we get 4.5. 2.25 for y. And always make sure those make sense. That's bigger than 1.5, and that makes sense because it's a bigger triangle. And 4 is smaller than 6 because it's on the smaller triangle. Right? Alright, we have about 2 examples left. So notice on this one, we know the area of one, and we know parts on this one. And so I got a little bit distracted not looking at this correctly. But notice we know the base and the height of that triangle. So the way that we're going to go around this is we're going to first find the area of that triangle by using the base of 6, height of 3. So we get the area to be 9. So I now know that the ratio of the areas is 9 to 64. So to find the area of the sides, remember, I'm going to square root. And I get 3 over 8. So that's the ratio of my sides. Right? And so now I know the ratio of my sides is 3 over 8. I'm going to use that to find my missing pieces. So 3 over 8 equals 6 over y. And I also am going to set up another one. 3 over 8 equals 3 over x. Now this one's easy because you can quickly see that x must equal 8 in order for those proportions to be equal. Y takes a little bit of work. We get 3y equals 48. Divided by 3y is going to then equal 16. And again, always check to make sense. 8 is bigger than 3, so that's the bigger triangle. 16 is bigger than 6, that's the bigger triangle, so it makes sense. Right? So the idea is that one dimension is length and 2 dimensions is area. So again, our ratios are m over n, so then it's going to be m squared over n squared. So 2-dimensional is why we have the squareds. 1-dimensional is just m over n. Right? So our last one says 2 similar triangles have a ratio of sides of 3 to 4. What's the ratio of their areas? So our ratio of their sides is 3 to 4. To get the ratio of the areas, you should be thinking square. So I get 9 over 16 for the ratio of their areas. Right? So now you have a chance to get started on your homework. Please rewind the video if you had any more questions or need any more help.